Alright, so in this video I'm going to be talking about the latest updates to the Tycho software. Now for those of you who may not be familiar, Tycho is a tool that employs the synthetic tracking technique to improve the detection of asteroids. So I have other videos that cover that in more detail, but for now I will just talk about these updates. Tycho has been in development for a few months now, I guess going back to July, and it's still in sort of beta release. So certainly anyone in the community who has feedback on the program, I'd certainly love to hear from them. So for now, and in this video, let's go ahead and we can cover these updates. So this is now version 1.11, and the first two items concern the generation of reports. So when you have created some observations on an object, you would like to be able to submit those to the Minor Planet Center. So you do that by creating a report. And so there are now two ways to do this. Most of you would be familiar with the legacy MPC 1992 format. However, there is of course now this new ADES standard, which is that stands for Astrometry Data Exchange Standard, and there are actually two different formats available in this standard. So it permits a sort of XML markup, if you will, is one presentation that you could do. However, there's also now a pipe separated value format as well. So which a lot of folks are using this because it's more human readable, and so that is what I decided to implement on the Tycho software, is this format here. So you can now do either the legacy format or the new standard as well. And it also supports roving observatories, so if you do not yet have an MPC code assigned to you, then it will accommodate that as well. So these basically concern report generation of observations. These two items here, so once you have detected or you've come up with a track in Tycho, you'd like to know if that matches up with any known object. So is this potentially a new discovery or not? So the first way you can do that is compare with existing objects in the MPC orbital database, MPCORB. And so I am now using this matrix method. I'm not going to go into all the details, but it gives better accuracy for the distance measurement, if you will. Certainly better than just doing delta right ascension, delta declination, and taking the square root of the squares of those deltas. Yeah, so this is, and in fact I've already been using this method for other parts of the program, computation of asteroid speeds and so forth, but I've forgotten to employ it for this aspect of the program. So now, to the best of my knowledge, the Tycho software now is using this method everywhere, so that's a good thing. And next item is, if the closest object is farther than 2 arc-minutes away from the detection, then we simply say that there is no match. So previous version would say, well, we found this object, it's pretty far away, but we're going to go ahead and list it anyway, and it's up to the user to decide whether that distance qualifies as close or not. But yeah, this is actually better in my opinion, because it cuts to the chase. It says, hey, this is worth checking out, and you don't have to weed through scanning through a whole bunch of objects to decide whether or not there is a match or not. So finally, we have improved optimized motion functionality. So it comes up with a track. It says, hey, here's the motion that was determined for it, but you may or may not, 99% of the time it's going to be just fine, but for some objects there might have been a better motion that it could have come up with. Again, that's dependent upon the parameters that are chosen at the start of the synthetic tracking run. So if you chose a step size, for example, that had not sufficient granularity, then there's potential that it could have actually come up with a better motion. So anyway, that's what that feature is for, and it's now been improved upon. Okay, we might be interested now in looking at these updates and seeing how they actually play out. So I have a data set here. These are from 4K by 4K camera, so they're pretty big. This 16 megapixel camera, the 32 megabytes per file, and there are 33 of them. So I'm going to go ahead and load up the saved results that I did. So I'm not going to go through the process of running Synthetic Tracker. I'm just going to present those results. And so this is the track navigator, and so 86 tracks were detected. So I'm just going to go ahead and again MPC orbital database. So we're going to say which of these detections were line up with a known object. So yeah, so every item here that has these columns filled in are actually known objects. So object distance, this is in arc minutes, so 0.18 arc minutes. That's pretty close. And so you can see most of them actually are real or known objects already, but there are a few that did not match up with a known object. So let's go ahead. Before I go further, let me go ahead and load up the star catalog. So this will get me the photometry information, so we can look at magnitudes. Yeah, so there's a lot of data go through here, so almost finished. Okay, so we now have the magnitude column has been populated. And so again, the way the track navigator works is the first item, and it's sorted by track quality. So you'd expect the first item to certainly be a real asteroid, and certainly that's the case here, as you can see as I go through the positions here. Yeah, I can zoom out if I wanted to, and then I can go to other detections. So I'm actually just scrolling through each asteroid, so you can see these are all different asteroids actually. And you might think, gosh, is this really 86 unique asteroids? A few of these are in fact duplicates, but the vast majority are unique. I would say easily at least 65 of them are unique, and you can just look at that here. By this column, this is the object name, and so a good number of these are unique. Now, okay, so here's something that would be interesting to, I think, most of you. So let's go down to here is an object, a detection that had no matching NPC object. So you might wonder, well, is this a real object or not? So yeah, we can go ahead and take a look at its track. And so that's pretty faint. Let's zoom in a bit. Yeah, first off, you can certainly do this technique. You can stack them like so, and according to the motion of the object. So that looks pretty good. That looks like it's definitely a real object there. And I can certainly, oops, I hit the wrong key. Let me go back. So yeah, you can certainly animate that if you wanted to, and that's what I'm doing here. So to me, I would say that's certainly a real object. And one way you can verify if it is or not, well, maybe is you can copy these. Now this is not the new report. This is just a quick and dirty way of getting an NPC formatted list. So this is not the new feature. I'll get to that in a bit. But for now, for this purpose here, we're just interested in determining whether or not this might have been a potentially line up with a known object or not. So it wasn't in my MPC orbital database file, but maybe it's in MP checker. Well, it actually is kind of far away from, this is the closest object, and I would say it is really still an unknown object. So unfortunately, this data set was captured back in September, and so at the time I didn't really know what all I needed to do to get follow-up observations, that sort of thing. I was just collecting data for development purposes. So now that I revisited the data, I say, well, gosh, this could possibly have been a nice discovery on my part, but such is life. So now you might think, well, okay, how about, in fact, I've already looked at this data, so how about one that we know is a real object that just didn't match up with my MPC file? So here is a real object, for sure, a real object, definitely. And again, we can do the same thing. We can stack it according to its motion. That looks pretty good. If we wanted to, we could animate it. So again, this is same kind of behavior we saw before. And let's go ahead and get the lists here. Again, this is just this is not an official report, but it permits us to run this tool on their website. So come up with a list of known objects close to these observations, and now you see this is actually, so 0 and 0, so very, very close to, it is basically this object. So 2018 RT13. Okay, so now here's the interesting part, in my opinion, and I think some of you will find it interesting as well. So this is a magnitude 18.6, okay? Magnitude 18.6, and again, the synthetic tracking detected it, okay? I mean, this is quite nice in my opinion. So you might think, well, mag 18.6, that's not too deep. But guess what instrument this is taken with? This is actually taken from a 127mm refractor, a 5-inch refractor. So that's right. So that might have been your question earlier, is how did we come up with so many asteroids? Well, a refractor has such a nice wide field of view. This is actually a 3-degree field of view, 188 by 188 arc-minute field of view. And even though it's just a 5-inch telescope, the synthetic tracking technique was able to pull out detections of these very faint objects. And again, this is a real object. This isn't just some pattern noise or something like that. This is the real deal. So okay, so yeah, I think that's interesting, and I think it's pretty cool. So back to the updates, the report generation. So if I wanted to create observations, again, I could do that. I'll just create a few here briefly. So I can create an observation on that, and then create another one here. All right. Again, this is just for demonstration, so I'm not going to create a whole bunch. Just these 4. And so again, I can do the new format, the new standard, or the legacy. So let's just start with legacy because we're familiar with that. So I can put in my station code, my MPC code, or if I were a roving observatory, I can check that box and fill in the details. And so, but I have a station code, so I'll click OK. And this is a provisional designation. So what was that? This 2018 RT1, I believe. I'm sorry, RT13. RT13. So I'll put that in. Oops. Okay. So for some reason, oh, it wants the packed form. Sorry. Yeah, they're interesting in that way. So if it needs it in the packed format, then what you can do is you can say, okay, unpacked in 2018 RT13, and let's go ahead and pack that. So that will be this designation here. So there we go. And so you now have your MPC format. And you can copy to clipboard if you wanted to, or you can save to file, that sort of thing. Alright, so what if I wanted the new standard? Well, same thing. I can put in these report parameters, and I click OK, and now you have these three fields. So a permanent ID, this would be like the MPC number if it were assigned a number. Well, it has not been assigned a number. Provisional ID. So in this case, this is where the two differ, is that they do not want it to be in packed format. So I would actually put it as what I was trying to do originally, 2018 RT13. And a track ID, I can put that in as well to indicate the in this batch file. This is my observation observer assigned identifier. So this is what that looks like, and so it has these columns, and so this is another way of doing it. So you now have two ways to generate reports that can be submitted to the MPC. So all right, well, that's all I have for this video, so thanks for watching.